Hello everybody, this is a continuation of the previous class on JavaScript basics, okay? And in that class we talked about variables, talked about data types, conditionals, control flow functions. But I promised that I was going to create a more detailed video on each of these, alright? I wouldn't call it deep dive, but I'll just say more detailed video on this concept. But definitely there are more to these concepts that you would need to learn, and then you will learn those along the way. All right, so variables. For variables, I told you we have let, keyword, we have const, we have var. When a variable is declared in the let keyword, the let name equals John. This variable can be changed. All right, so I did not explain what I meant by it can be changed. So this is called variable definition, all right, or definition. So you are defining a variable here. You are simply stating all that there is to the variable. Okay, so for instance, I'm saying let variable name equals John. I am stating the name of the variable, that's creating the variable, and then assigning a value to it. That's variable definition. Variable definition. But then I could have done what is called variable declaration. So when I do something like let age, right, this is variable declaration. So what I'm doing here is that I'm just stating that, oh, there's a variable available called age. All right, so I create the variable. That's just declaring that I've made the variable called age available. But then this variable has no value. And if you remember the last time I taught you that if that variable gets used, the value assigned to it will be undefined, because undefined means that there is no value assigned to it. So when you declare a variable like this, or when you create a variable like this, it is called variable declaration. Then variable definition means that you would create the variable, and at the same time you would assign a value to the variable. So that's the difference between variable declaration and variable definition. So now I have John. So back to what I was saying before I was interrupted. I said when variables are created with the let keyword, they can be changed, all right, during the course of the program execution. You can decide to change them. So when we do something like I'm going to get rid of this. So when we say let name equals John, at some point we can use the variable. Let's just use the variable here, name. All right, so we're saying log name to the console. Okay, so at line 6, I'm going to say name should now equals Austin. All right, and then I'll say log name to the console. If we go back, we'll see that the first time name was logged as John, and the second time name was logged as Austin. The first time name was logged as John, and the second time name was logged as Austin. And why is that? The reason is because here we do something called variable assignment, or you can call it reassignment, all right? Because the component of the variable definition is the variable declaration and the variable assignment. So we did this in one line. While line 6, we reassigned the variable name to point to what? Austin. So at line 8, when we try to retrieve the value of name, we're going to get Austin. Now this is how to think about it. I told you during the last class that JavaScript would execute from top to bottom. So let's call this year 1991. So year 1991, this person used to bear the name of John. Somewhere down the timeline at year 2005, if you want to call 2005, sorry, if you want to call this variable, right, what you get is John. Let's assume this user. All right, so let's call the user name John. Okay, just so that my explanation makes sense. Username, user name. All right, so the username in the year 1991. So reason these line numbers as a timeline, all right, like history. Okay, so line 2 is year 1991. So at year 1991, this guy bears the name John. The username is John. Because of that, at year 2005, when we wanted to get the username, we got John, because at year 2005, this guy's name is John. But then somewhere down the line, the username was not changed to Austin. So this user changed his name to Austin, and that will be in year 2024. all right. Year 2024, this guy changed his username to Austin. So it means that at any moment in time from year 2024, line 6 down, right? If we want to refer to this guy, we know that his name is not Austin. So if we try to retrieve his name from our database, right, what we should expect is Austin, all right? So that's why you see Austin printed here. John printed first, and somewhere down the line, Austin is printed. Okay. I said this all to say that you can reassign variables. So a variable that points to, so if we go back to Xcali draw, a variable that points to this at some point can be reassigned to point to this, for instance, or reassigned to point to this, or anything that we want. All right. So that's the meaning of the term variable. It means it's something that can change. It can vary at any point in time. All right. But then we have a special type of variable. So what I've just explained now is true for let, the let keyword. When a variable is created using the let keyword, and when the variable is created using the var keyword, right, the same thing applies. If we go back to, you see that John is still being printed and Austin at a later point in time. All right, but then we have a special keyword to create constant variables. The word constant variables is going to make sense when I explain how it works. All right, so if I change this to constant, we're going to get an error, because what we said is that username should always point to John. Username should always point to John. All right, that's what I've said. Constant, it should constantly point to John. I'm creating a variable, but this variable should constantly point to this value that I have assigned to it. Okay. If I go back now to the browser, I should be expecting an error. There's an error there that says uncaught type error, assignment to constant variable at line 6. All right, app.js line 6. If we check this app.js on line 6, at line 6, we're trying to reassign a constant variable to point to something else. That is not possible. That's the consequence of using the const over let or var. There is more to this, but like I told you in the last class, I'll leave it for when we talk about the execution context and how all those things works. All right. So having said this is a constant variable. Take note of the term constant variable. So I'm going to get rid of all these comments and I'm going to show you something. Now remember that we have different variable types. There is the variable that can store multiple values, e.g. arrays. This is an array, an object. Now these variables are called reference type variables, but let's not go into that. So we'll go into that when we start talking about types. This by way of introduction to types. If this variable were to be an object, stay with me, that has a name of, so I'm going to call this user. All right, so the name of the user would be Austin. The age of the user would be 12. Okay, and I'm going to get rid of all this. Now watch. This is a constant variable. It's constant, but it's still a variable. It means there is room for some kind of changes to occur. But get me. Now if I say console.log, no, not console.log now. If I try to reassign, all right, say user should not be equals to 12, I'll get an error. Assignment to a constant variable at line 7 has given us an error. So line 7, I'm saying user should be equal to 12. Even though I said at this point this should be a constant variable, it shouldn't change. All right, so the constant part has been fulfilled. What about the variable part? So it's a constant variable. All right, it means that the values inside this object can be changed, can be altered. All right, please take note of what's happening. So I'm going to make this very clear, all right, by using this illustration we have here. If you look at this illustration we have here, let me get rid of this. No, get rid of this and get rid of this. If you look at this illustration, we're going to make this user, and in fact, let me copy this. That's the value. Okay, so it makes complete sense. Okay, so this is the value that the user points to. So user points to this value, right? I cannot at any point in my program, so this is const, right? I can't at any point in my program now say that user should point to something else. I can't say that. This is not possible. So once you say const, like constantly point to this. That's what you have said. User should constantly point to this value. So you cannot at a different point in your program say user should now point to something else. You can't do that. But what you can do is to say that I want to change the age component of user. Are you seeing the technicality now? I want to change the age component of user, all right, or the age property of user to become 14. So when you do this, what happens is that if you try to access the user property console and log user, you will see that age would have changed to 14. So let's try it in our code. So age is 16 right now, but I'm going to say user.age should be equals to 12. All right. So if I save and then console the log user, you should see that age is now 12, even though before the change happened in line 11. So let's console the log user. So at line 11, before the change, that's going to happen now at line 13. User should have age 16, and after the change, it should have 12. So if you come back here, you see that it has 16, and after that change, it now has 12. Okay, I can make this better by saying before, then after. All right, but I hope this makes sense to you. So before is what the object has for age, and after, this is what it has. So I said all that to say that it's a constant variable. It will constantly point to this object, but the properties can be affected or can be changed. Any of the values that it contains or it stores can change. All right. So this is possible because this is a complex type. It's not primitive. All right. The word primitive, I would say it means simple. This variable is a primitive variable. So if I say const username equals Austin, this primitive is a very simple value it's storing. But as you can see with your own eye, this is more complex. This is a more complex value, all right, than this. So values like this that are single, like single value, they're primitive values, all right. Then these are called reference types. So having said this, let's go into the concept of data types now. I think we've already started talking about it, but let's see if there is something more to talk about. So for data types, it's like I said, we have different data types. There is string, there is number, there is boolean, all right, there is symbol, all right, there is a null, there is undefined, there is function, there is object, there is arrays. I don't know if I'm missing any of them, but I think these are pretty much the main guys. Okay, so I'm going to make these lower cases because the guys here at the top are called primitive. The guys here at the top are called primitive data type, whilst the one here at the bottom are called reference data type. Okay, primitive data types are simple, one value. They're simple, they have a single value, while reference data types are more complex. They store complex values. So let's talk about them one after the other. For strings, I told you strings are a group of characters delimited by quotes or enclosed by quotes. You have a variable, say, let's say let address equals stuff Jack Joe Drive Nelson close. So this is an address, and you see it's stored as a string. Variables that you would store as strings would be variables that have characters as their values. If it's a text, you want to store it as a string. I told you the last time you can compose strings by using double quotes or single quotes, right? Or backticks. But you want to make sure that the same type of quotes is used on both ends. That's what you want to make sure. But that's that about strings. There are a lot of things you can do with strings, but I think this is like the basic use of strings. Strings have some helper methods that you can use on them. For instance, I can say address.length. All right, this is going to return the length of this string to me. All right, it's going to return the length of that string. Address the length, we can't see this now, so I have to log it to the console to see what the value is. So console the log, we go to the console, that's 32. So this is a 32 character string. So 1, 2, 3 spaces are counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So you have 32 length, string. Okay, so you can get the length of the string. And let's say you have a question that says write a function that receives a string and then returns its length. This is what you would use address.length. You write a function, which I'm going to teach us how to write, and then it should return address.length. All right, so that's the way you would answer a question like this. There are more methods that you want to check out. Okay, we have the variable declared here. All right, and the file is loaded in the browser, so I can access it. The address the length will give you the length, all right, of the string. Dot split is going to receive a separator, and then it's going to return an array version of it. All right, so we said split address. All right, we're saying split address, all right, using a comma. All right, so when you look at this string, you see that there's a comma here. So when it finds a comma, it's going to use it to split the string into arrays, and that's why you see these two values here. Okay, you see more of them. There's concat. You can add another string to address. So if I do address the concat, I can do something like this. Let's say life is good. So the result of that is that this string will be added to address. So concat is short for concatenate. That's to join together. All right, so you see life is good has been added to the address. All right, so there are many functions that you would get to know about with experience. Okay, and I think that's enough for talking about strings. Next thing we want to talk about is numbers. So for the number type, you have figures. Say score will be equal to a number 12. All right, and if we log that to the console, you see that score is 12, and the type of score is number. Okay, any type of number, all right, is still a number. All right, if I do E10, all right, still a number. Okay, so let's print the value of that now, and you see that it's a number. Okay, so there are different ways of writing numbers, but for now you can be concerned with just the simple way to write numbers, which are integers or doubles. All right, integers or floating point numbers. All right, so when you have something like 12, that's an integer. I have something like 12.5. All of them are classified under the type number in JavaScript. Okay, I think that is that about number. There are some things you can do with numbers. You can add numbers together, you can subtract, you can divide, so different mathematical operations. Okay, so I can say score divided by 2. And I told you that during execution, wherever you mention a variable, what you will get is the value of that variable. So during execution, what will be here will be 12.5. Okay, that's what you will have here. So we say score, which is 12.5 divided by 2. All right, and if you check, that should be 6.25. So you can perform different mathematical operations with numbers. And then for Boolean, this can be true or false. All right, booleans only have one of two values, which is either true or false. So I'll say let is married equals true. So is married here is a variable that has the type boolean. Boolean can be either true or false. So I'm going to say console.log is married, and you see that we get true. Okay, and if this was false, you see we get false. So booleans are useful for conditionals. So if this thing is true, do this. If it is false, do this. If the memory is full, reject incoming requests. If it's not, accept. So basically, you find booleans useful with conditionals at different points in time, and also for loops. Even in loops, they are also relevant within the scope of conditionals. Okay, so that's boolean for you. Nothing too deep to talk about. Now I talk about the symbol type. Now the symbol type is something that I myself have not found useful in terms of everyday programming, but it is useful. That's why it exists. Okay, but the symbol type allows you to create unique values. So I'm going to show you how. So if I say let sim to be symbol 1 equals symbol, all right, h, and then I'll come here and create another symbol 2 to be h2, right? Now let's compare. I'm going to say sim1 equals to this triple equals 1 2 3, triple equals sim2. So I'm comparing both of them. What would you expect? Now this is 1, this is 2, so they are technically the same. They're supposed to be the same. But if you check the result, you see that it is false because every symbol you create is going to be unique. All right, every symbol you create is going to be unique. So that's something about symbols. The applications, there are lots of applications that we don't get to talk about for a basic class. All right, but you get the gist. Symbols are used to create unique values. So whether the declaration is the same physically, but behind the scene, as long as it's a symbol, it's going to be unique from every other symbol you've created in your program. All right. If this were to be a normal value, we could say 12, 12. Are they equal? Is in 1 equal to 2 now? You see true. It's true. Okay. But for symbols, it's not, it doesn't behave like the normal values. All right. So yeah, that's it. So moving on to the next. For null, these are the two simplest that you can ever come across. For null, null simply means that the variable points to an empty value or it points to nothing. So it is null. That means it points to nothing. All right. So if I say let planet points to null, all right. So what I'm saying is that planet points to nothing. So when you see this will return null. Surprisingly, the type of a variable that holds a null value is object, and that's a mistake, as I told you in the last class. Okay, so just take this as one of the mistakes of JavaScript. This is supposed to be a type of null. All right, but the meaning of null is that it points to nothing. All right, and undefined is kind of similar to null. Undefined works as intended. So undefined, so I'm going to say PhD score, and then type of PhD score will be undefined because you've not defined it. You only created it, but you've not defined it. You've not given it any value. That's what it means. So if you remember, during the last class, I told you that there's a difference between variable declaration and definition. In variable definition, which is defined definition, you would have let PhD score, that's the declaration of the variable or the creation of the variable, and then you give it a value. So 20. So you have defined the variable. That's why this is called variable definition. You have defined the variable. But in the case where you do not provide any value, you have not defined it. You just declared the variable. I hope that makes sense. So the default value that will be given to it by the JavaScript engine is going to be undefined. So the type of an undefined variable is going to be undefined. All right. So that's undefined for you. So what's the difference between undefined and null? It is but null values means intentionally you have stated that the variables do not hold anything. But for undefined values, it means that you have not explicitly given it a value and the compiler has gone ahead, or the JavaScript engine has gone ahead to give it a value for you, and that value will be undefined. So you should use null when you intend to assign an empty value to a variable, and you should never use undefined, because JavaScript uses it internally to mean something. All right, so don't confuse the language and avoid using undefined. Use null instead. Okay, moving forward to reference types. So I'm going to go ahead and delete all these. So what's a reference type? A reference data type is simply values that are stored by reference. So let's go back to our diagram. What happens is this is an improvement of what I've taught you before. So what happens is this, technically speaking, I'm not saying literally, I'm saying technically. When you attach values of the reference type to variables, what will happen is that you have a reference in between. I'm just going to just make up something, all right? And then that reference would now point to the value. What does that mean? For primitive types, it's just direct. It refers to the value directly. But for reference type, your variable name is going to hold a reference, and that reference points to the actual value. So what's the implication of that? What does it mean? What it means is this. For instance, let's create a variable and say let age equals 12. Now if I say let age 2 equals age, what do you think I've done? Knowing that whenever we mention the variable, we're actually mentioning its value. That means during execution, all variables will be replaced with their value. So let's assume that this line is executing. What do you expect? It means that age here is going to be 12, right? So because of that, if I say console the log age, I'll get 12 in the console. And if I also say console the log age 2, I would also get 12. Now this is the interesting part, right? If I say let age 2 be equals to 14, so let age be equal to 14. So if we go and check, see that we still have 12. Why? Think about it. Know that the program runs from top to bottom. So at this point, line 2, we say that age should be 12. Let's represent that visually. Let's see. At the first instance, which happens to be line 2, we say age should be equal to 12. Just follow me closely. Age should be equal to 12. And then somewhere down the line is our timeline, program timeline. We call it program timeline, right? Somewhere down the line, we now say we want to create another variable called age2, but we want it to be equal to age. What that means is that it should equal to 12, right? That's what we're saying. We're saying it should be equal to age, and age is going to resolve to 12 during execution, right? Yeah, so this will be 12. Then somewhere down the timeline, we now say let age, instead of age to be 12, we want age to now point to another value. Let me illustrate it better like this. Age equals 12 gives us this, right? Age 2 equals age, and let know. Okay. Let age 2 equals age, we give us this. Right, and then somewhere down the line we now say we want to reassign age to equals 14. All right, what that does is that this is not created anew, like the variable age is not being created again. It already exists, and this is this, but now there's a value that we have created, 14, and we're saying that age should no longer to point to 12 but should point to 14. That's what I said. All right, but the program makes a downward progression, like it moves towards the future. It wouldn't come back to come and declare this again and say this should now be 14. Do you understand? This has been executed to be 12 already. Age is 12, right? So it remains 12. That's why when we come here and console the log age, we're going to get 12. Sorry, age 2, we're going to get 12. All right. I hope that makes sense. We're still going to get 12. All right. Because at the point of execution, this has already been resolved to be 12 and assigned to this. So when we change age, we're only affecting this. We're not affecting this. But it should make more sense when I compare this side by side with how reference data type works. These are primitive data types. They are passed by value, not by reference. All right. You come here, you see what that means is that they are passed by value. So it's stored directly to the value. All right. The variable is the value. But for reference data types, the variable actually resolves to a reference, and that reference, wherever it is required, is going to provide the value. So there's a middleman called the reference. So we go back here and try this with a more complex data type. So I'm going to call this user, and the user is going to be an object. Age will be 12, and address would be whatever I want, John Doe Street. All right, I'm going to get rid of all these guys. Let's try something. So I'm going to say let user 2 equals user, and at a later point in time I'm going to say user should be equals to, make it different, name Victor and complexion. Okay. All right, if I come here now and say console the log user 2, let's see what we get. Just take a look at it. What are you expecting? We said let user be equal to this. All right, let user 2 be equal to user. That means technically this should be here during execution, right? Because variables will be replaced with their values. All right, so we know that user 2 has an object that looks like this. And now we'll now change our mind and say, oh, user want you to point to something entirely different now, which is this. Right? Then now we say console.log user2. What do you expect user 2 to print? Would you print this or this? Note that user 2 was set to be equal to user. All right, so make your guess and I'll make my guess. So my guess is that this will be printed. So let's check. For printing user 2, remember, I guess that this will be printed. So if I refresh, we have age 12, address John Doe Street. All right, John Doe Street. Wow. John Doe Street or John Doe Street. All right, so that's what it printed. So now let's see what happened. So what happened is that I'm going to copy this. What happens is that we have said let user equals this, right? And then let user 2 equals user, and then we now say user should point to something different. Yeah. And now we console the log user2. So I said what we expect should be this. And that's what we got. So let's analyze the code. So let's analyze our code here. All right. So this line of code is going to result to user pointing to a reference. Let's say ref. All right. And that reference would hold the value, the actual value, which is this. All right. And then at this point, we're saying user2. So we're creating user2. User2 now points to this reference. Notice that it doesn't create its own variable like this does. It points to the value of another variable. In this case, right? In this case, actually, at this point, we're just going to it doesn't point to this, it points to its value. All right, points to the value. So that's why this value is now copied. All right, to copy. So the consequence of that, so this should be age. The consequence of this line of code is that we have copied the value 12 to this guy. All right, so it points to that value, it copies it to itself. All right, that's why you get 12. Okay, but in this case, what is being copied is the reference. All right, so this would have this reference. And what is this reference now? This reference points to this value. I hope it's making some sense. All right, so therefore when we come here to user, to this line, and say user should point to something different, what we are simply saying is user, don't point to this anymore, you need to point to something else. So this would now point to something else. And let's say the new reference for this object is ref, right? And that's what it points to. And the value for it would be this, right? So therefore, this relationship no longer exists. So this referencing is dropped, but this guy still refers to this object. All right. So when we say console the log user2, we know that user2 still refers to this, and this refers to this. That's why we'll get this value returned to us. Now it seems like it's a lot of stuff to understand, but once you get it, that's it. Like immediately you get it, that's it. You don't, it becomes too simple, you know, and you ask yourself why it took you so long to understand it, right? So take your time, look at this diagram, and you'll see how it works. Okay, so I'm not done with my explanation of reference types, right? For reference types, there's something else you need to know. So let's run a piece of code, all right, and say at this point, right, at this point, we're going to say user. So we'll get rid of this, but now we'll say user dot age should be equal to 15. What do you think would happen if we print user2? Think about it carefully. Based on what I know, I would guess that user2 should print an object that looks like this. All right, here should print an object that looks like this, but with the value of age being 15. So if we check our console, we'll confirm that age is 15 for user2. Why do you think that is? That is true because user and user2 are pointing to the same object. Let's prove that once more by going back to our drawing board. And then I'm going to copy this, right? So let's refresh our mind. So user, at the first instance, we said we created user. User has a reference that is auto generated for it, right? And user reference points to this object, right? Points to this object. I'm gonna make this white, right? Points to this object. And user2 was created. But when user2 was created, we now said it should be equal to user. And I told you that user will resolve to its reference, not its value. Unlike primitives that resolve to their value, this will resolve to its reference. And when we use the reference, we get the value. All right. So user2 in this case, we're saying it should be equal to user. All right. So what that means is that it's going to point to the same reference as user. All right. So it's pointing to this. Okay. So at this point in time, we said user.age should be equal to 15. What's user? User would refer to its reference, which is this. So it's like saying that we want this dot age, and this reference dot age is what, 12. But now we're saying that reference dot age we want it to be 15. So I've changed this to 15. It will now come down and try to console log user. Remember that through this point, or at this point, we have changed, I think we're logging user 2, right? User 2. So if we try to log user 2, what does user 2 point to? What does user 2 point to? User 2 points to this reference. And what does this reference resolves to? It resolves to this object. So that's why we get 15. That's why we get the object with the age 15 returned back. Okay? So if you replay the video and just go back and forth, all right, this concept will make sense. This is not usually easy to explain, but merely you understand this concept is going to help you avoid a lot of errors. Knowing that primitive values are passed by reference and an object is a primitive value, a function is a primitive value, it is passed by reference. An array is a primitive value, it is passed by reference. So when you know how to pass primitive values and you know the consequence of doing so, you'll be able to avoid a lot of bugs. For now, it might not completely make sense, but as we keep building on these concepts, they are going to make complete sense to you. Okay, so I'll stop here. I just used objects to explain reference types, so I've not gotten into these and these, right? We are still here at reference data types. I just use objects to explain that. In subsequent videos, I'm going to be explaining how functions work, how objects work, arrays work, and I'm going to buttress these point I was trying to pass across to you on how reference data types are resolved. Okay, and then we're going to continue with conditionals, control flow, and functions. All right, so till I'm able to record those videos, do take care of yourself. I'll see you next time.